You can kind of jam on this like it's a accordion.
Like a guitar?
Yeah. And it feels more romantic that way.
It does. What is this thing?
It's a stylophone. Maybe one of the first products with a real stylus, I guess.
Yeah.
You know?
One of the first products we've ever tore down, or like ever?
I don't know. Can you think of anything? I mean, the thing's old, right? It looks old.
The stylophone is used by David Bowie in the track Space Oddity.
Do you know it was also used by the Beatles, Kraftwerk, Queen, and Vangelis, who did the soundtrack for Blade Runner?
That's pretty cool. So it's a very important historical instrument, despite being a funny toy. Toys, they're important. So just like some quick analysis of this thing, as you mentioned, Ted, there's a potentiometer on the back, and then we have the stylus on the front. The stylus is wired.
Very high tech.
Very high tech. And you complete a circuit to these different pads here.
There's a volume dial. This is kind of like a pitch or modification switches here.
I think they call it the instruments.
The instruments.
It has 3 instruments.
Let's hear those 3 instruments. Instrument 1. Instrument 2. And 3.
Okay, maybe it's just 3 different octaves.
Like voices, yeah.
Yeah. And then there's a vibrato.
On and off. Okay, that's great.
What does the vibrato do?
Like the you know, like when you do the
Yeah, that makes sense.
and then power.
And power. And then because it's for serious musicians, it has an audio in.
Right. I wonder what that does.
This thing's great. All right, I like this thing. I'm gonna buy one.
Should we tear this down?
First of all, ta-da! It's open. It's basically like a project box with all the components laid out here. And we'll get into this in a second. This is like the main PCB. It looks like it has the contacts on the top. But just like a note on how this is closed, it's got these weird little heat stakes in the corners that nub into here, and then they somehow weld it. It might be with a glue. It looks like there's some residue of a glue or a chemical like bonding agent, but that's it. It's got 4 snap points between the top and back, and then they like weld it so it stays together in shipping. But that's it. It's almost like it was designed to be opened and hacked. So it looks like they also have this big plastic piece here. My guess is because you have the keys in this area, you can't put screws through it, right?
Right.
And so I think they have this little plastic bridge here to bridge between the housing and these screw bosses over here. And what that does is it creates a place where the keyboard is nice and stiff. It's sort of like the metal pieces we saw in the Automatone. And then the speaker has no mounting features, so they use these little plastic pieces here to hold it in place.
It's a very bare board because these are basically exposed pads that allow the circuit to be closed.
Just like a quick recap of the architecture of this, it's a really simple clamshell design. It has, it's designed for 1960s injection molding. There's not a lot of like aggressive undercuts or anything like that. It's just a direct draw from the tool. There are these really funny snaps on the side which appear to be chemically welded to the inside of this housing. And then everything's screwed in. All of the screws are this like nice, small, consistent size, except for these, which are used to hold the speaker down. The speaker has no mounting holes, so we've got these little brackets that press it into place. And because the board is unsupported in the middle by screws, there's this nice little bracket that holds the music switch in the front, the instrument switch in the front, and then also supports the back side of the board. That's really it. Other than that, there's an integrated battery holder here, and then everything else architecturally is built into the PCBs.
So in the PCBs, the main board is the keyboard. It's an FR4 with no mask, and that's how they're able to expose the actual keys so that you can close the circuit. This is the removed stylus. The stylus wire actually goes through this board. They've knotted it, and it goes into that second board. We think that everything related to the speaker driving is over here, although we can't really figure out sort of where the actual sort of like
Signal generation
is being produced. There's two potentiometers, one that controls the volume here with the dial, and then the other one that controls the pitch shifting on the bottom here. And then the switches here, power and vibrato, and the speaker. I think the other thing to point out is that under this blob of glue, which is common in electronics, there's something happening there. It's impossible to figure out because this is very hard.
But it's probably a die level part wire bonded to the board, and something that's old and works well. What's curious to me is the Automatone was very analog.
Yes.
And had very large analog components across it. This one seems very analog as well, except for this component here, where all of the switches, all of these buttons go into it, and then different traces run out back to this like signal generator circuit, out to the input and output audio. So it's I'm fascinated what it could be doing.
So the lines from this board go back to the headphone port. Mm-hmm. So I think that is involved in the production of the audio, as well as like the speaker itself plugs into here. The sort of like voices or the instruments run into here as well. So I looked up this part on this second board. It's the LM386N from Texas Instruments. It's a low voltage audio amplifier. So the only thing that this board is doing is just amplifying the signal to drive speaker and the line out. So yeah, all of the music generation is under here. We did some quick research on the Stylophone schematic online, and essentially what's happening is each of the 20 keys here has a fixed resistance, so that when you close the loop on a particular key, there's a different resistance that's associated with that. And through the analog circuitry magic, they are creating different tones through running it through a series of op amps and square wave or triangular wave generators.
The schematic we looked at looked like there was a square wave coming in. It goes through these resistors. When it recombines with the original square wave and the change in resistance, you get what they're calling a triangle wave in the schematic, and that's the tone you hear.
So let's get the oscilloscope so we can take measurements of the speaker and see how it works. The Rigol DS 1052E.
Yeah, it's got all sorts of features. Basically what happens is you put a signal through one of these probes. You can optionally ground the probe to your ground of your circuit, although it has an internal ground too, is that right?
Yeah, sure.
And it displays the signals on here. So this usually displays voltage over time. And so it's a great way to take a really accurate voltage measurement of something, or see the waveform coming out of a speaker.
Exactly.
So we're going to hook this up to the speaker. What?
The speaker!
The speaker? Cool. So you can see our waveform here. It really is a triangle wave. It's very, very sawtoothy. And so if we go up and down the scale, you'll see these bumps get closer and closer together. And that's because the frequency is increasing, right? This is a constant time scale, and as we go up, more bumps happen within that time scale. It's a higher frequency. Cool. Hey YouTube, I hope you enjoyed seeing us take apart the Stylophone.
Remember to like and subscribe. Let us know what we should take down next. We've done 2 audio products at this point, so yeah, I don't know.
We could do more things like that. We could do old tech, new tech, super new tech. All right.
Cool.
Thanks, YouTube.
Bye.
Bye. Oh, and happy birthday, Mom.